Dear students, today I will discuss with you some important MCQ from the chapter gaseous state for JEE and NEET examination. First question: if for the gases the critical temperature are mentioned like this is gas A, critical temperature Tc1, B Tc2, C Tc3, D Tc4, and the arrangement is Tc1 is greater than Tc2 is greater than Tc3 is greater than Tc4. Which of the following can be predicted? A. Choice A. Eg of liquefaction is minimum is given in gas D. Gas A has maximum value of van der Waals constant A. Eg of liquefaction is directly proportional to van der Waals constant A, and all of these. Okay, so out of these choices, you see what are the facts happening here. The critical temperature, which gas is having more critical temperature, is liquefied easily. So Eg of liquefaction is minimum in gas D. Okay, so because it has less, so Eg of liquefaction is minimum in gas D, that is it has less critical temperature and it is also less liquefaction. Okay, so gas A has maximum value of van der Waals constant A. What is constant A? So van der Waals constant represents intermolecular forces. Higher the magnitude of intermolecular forces, higher the value of A, that is higher the value of A, Eg its liquefaction. Okay, that means choice B also correct. Okay, it is supporting. Okay, Eg of liquefaction is directly proportional to van der Waals constant A. Okay, so I think all these are correct. All these are supporting. Okay, so from here what you learn? Higher the critical value, Eg the gas can be easily liquefaction. Okay, yes. Next, at high temperature and low pressure, so out of these choices, choice D is the correct answer. Okay, next, at high temperature and low pressure, van der Waals equation can be expressed like this. What? Okay, these are the choices given. Okay, so out of this choice, you see what is van der Waals equation? P plus A by N square V square, and it is your pressure correction. Okay, and V minus NB, this is your volume correction, is nRT. Okay, question number 2. So for n molecules it is like this, that is, then if you take 1, then P plus A N square by V square. Okay, V by V is equal to RT say. Okay, so if you take like this, then where V is very large, if V is very large, okay, if V is very large, then it can be neglected, and it is neglected. If V is, this is denominator, if denominator is large, then what will happen? It is very neglected. Therefore P multiplied V is equal to RT. You will get like this. Okay, so out of this choice, D is the correct answer. Okay, next, at constant volume, pressure and temperature are related as at STP temperature T0. So which one is what is the relation? What is the correct relation? You see, at STP we know what the relation pressure, the pressure P1 is equal to P0 multiplied 1 plus T by 273. Okay, this is the relation. Okay, at constant volume, pressure and temperature, these are related like STP temperature. P1 is equal to P0 1 plus T by 273. Okay, so applying Gay-Lussac law, you see, applying Gay-Lussac law, so that STP, question number 3, at STP, temperature is equal to T0, pressure is equal to P0, okay. So at time T temperature, so temperature in Kelvin, T plus 273, this much Kelvin, okay. So applying Gay-Lussac law, Pt by P0 is equal to T plus 273 by T0, okay. So what is T0? T0 is 273, this is T0, okay. So Pt is equal to P0 multiplied T plus 273 by 273, okay. So which one is the correct? You see, this one is the correct, okay. Yes. Next, if the ratio of Cp and Cv for a gas is 1.4, the number of atoms present in 11.2 liter of it at STP, standard temperature pressure, is what? Okay. So you know, question number 4. What is Cp? What is Cp? Cp is molar specific heat. Molar specific heat at constant pressure, okay. So for what is given? It is for the number of atoms present in 1 liter at STP. The ratio of Cp and Cv for a gas is 1.4. It is given 1.4. So see, Cp is molar specific heat constant pressure, okay. What is Cv? And its value is 5 by 2, okay, 5 by 2 R. What is Cv? Molar specific heat constant at constant volume, okay, and its value is 3 by 2 R, okay. So it is for monoatomic. It is for monoatomic gases. Monoatomic. Okay. So, and for diatomic, so its ratio you find. Its Cp by Cb. You for monoatomic. I will write again. See, Cp by Cv for monoatomic. What is Cp by Cb for monoatomic? Your 5 by 2 divided 3 by 2. So it is 5 by 3. So you will get what? You will get 1.67. For diatomic, what is Cp? Cp value is 7 by 2. Cb is 5 by 2. So its ratio Cp by Cb is what? 7 by 5 is equal to 1.4. So it is given 1.4. So 1.4 means here it is given 1.4 means it is diatomic. Okay. So for diatomic you see 22.4 liters were standard. For diet 22.4 liter is having 6.023 into 10 to the power 23 in multiplied 2 atoms. Okay, but here is given 11.2 because it is diatomic, therefore we are multiplying by 2. For 11.2 liter how much? 6.023 multiplied 10 to the power 23 by 2 multiple 2. So 2 to cancel, you will get 6.023 multiplied 10 to the power 23. So you will get this one. Choice A is the correct answer. Okay students, next question. The slope of the graph between log P and log V. Question number 5. The slope of the graph between log P and log V at constant temperature for a given mass of gas is how much? You see, we know Boyle's law, P is proportional to 1 by V, okay, or P is equal to K by V, okay. So we put log both sides. Log P is equal to log K minus log V. So we put in the equation y is equal to mx plus c. So here minus is given, that is minus 1. So slope is minus 1. So choice B is the correct answer. Next question. Equal masses of hydrogen, oxygen, methane have been taken in a constant volume B at temperature 27 degree in identical conditions. The ratio of volumes of gases hydrogen, oxygen, methane would be what? You see, question number 6. You let us take 2 mass of 2 weight of hydrogen. So it is how much volume? 22.4 liter. Okay. Similarly, 2 weight of you take oxygen. So how much volume will get? So 2 your 32 weighs volume 22.4 liter. For 2, 22.4 by 2, 32 multiplied 2. So it is 16. That is 1.1 something you will get. Okay. For methane you take 2 gram. So 16 gram weighs volume is 22.4 liter. So you are 2 gram 22.4 divided 16 multiplied 2. So it is 8. So it is 8 2 point something 2 point something you will get. So then the ratio is you are 22.4 is to 1 is to 1.1 is to 2.2 something else. So I think if you solve this, then you will get the 16 is to 1 is to 2. Okay. So choice C is the correct answer. Next, dipole-induced dipole interactions are present in which of the following pairs? So you read the question carefully. Dipole-induced dipole interaction. So where is dipole? You first see in the first choice, molecule. So here you see there is no dipole, but here is dipole. Okay. So here is cancelled dipole, and you see in HCl the dipole, but there is no dipole. So this dipole induced dipole here. So choice B is the correct answer. Okay. Next, maximum deviation from ideal gas is expected from which? These are the gases given. You see, among the gases, in ammonia it has the hydrogen bonding. So hydrogen bonding is the strong, it is easy for liquefaction. If hydrogen bonding is done, it is easy for liquefaction. So choice C is the correct answer. Next, a certain gas takes 3 times as long to fuse out as helium. Its molecular mass will be what? You see, question number 9. Okay, question number 9. So what to do? You see, we are taking the rate of that is molecular mass M2 by M1 is T2 by T1 time. Okay, it is the Gram-Slav division relation. So M2, a certain gas takes 3 times as long as effusion. So it is 3 times and it is 1 time. It's effuse as helium. So molecular mass of helium is 4 and it is unknown. So this is root over. So removing the root over, it becomes 9:1 is equal to m2 by 4. So m2 will be 36. So choice B is the correct answer. Next, by what factor does the average velocity of a gas